Okay, so we've got the 100-mile distance between the two ships. So put that 100 here, and I've got ship A moving north, and I've got ship B moving south. And I'm trying to find the rate the distance between them is changing. So I'm going to call that C. That distance between them is changing. So let's translate that. So I can have A here, B here, C, the distance between them is changing here, and then 100 here. So I've got to make up my equation of my triangle here. So I've got C squared is equal to A plus B squared plus 100 squared. So let's get the rates down that I've got. I'm given that dA over dt is 30 miles an hour. I'm given that dB dt is 25 miles per hour, and I'm trying to find dC dt. And the when is 2 hours later, t equal to. Save that until after the derivative. So now I'm ready to take the derivative. So 2c dC dt. Okay, this is the challenging part, taking the derivative of this. So I get 2, carry the inside along to the 1 power. Now I'm ready to take the derivative of the inside. So dA over dt plus, moving to the next term, dB over dt. All right, so now let's use the time of 2. So the distance of A will be 30 times 2, so that'll give me 60. The distance of B will be 25 times 2, so that'll give me a distance of 50. So let's cancel the 2's. Let's move slow here. So I get 60 plus 50, and then the rates are 30 and 25. And then I get to go find C. So A is 60. That's this distance. And then the distance from here to here would be 50. That would be B. And here's my 100, and then here is the C I'm solving for. So that'll be the square root of 100 squared plus 110 squared. So that will be what C is equal to. So dC dt be 110 times 55 over the square root of 100 squared plus 110 squared. Let's move on to this next problem. 2 women starting out running from different points. Sally's at La Jolla High, and Jenny's at the beach. The beach is west of La Jolla High. So Jenny leaves from the beach and heads east. So there's Jenny running towards La Jolla High, and she runs at 22 feet per second. So dJ dt is 22. Sally is running north, and she runs at 20 feet per second, so ds dt is 20. I'm trying to find out the rate the distance between them is changing. I'll call that C again, so find dC dt, and the when in the information that we're trying to use is 60 seconds, and I'm using that because they're running 22 feet per second. So that's the information I'll use to find out the distances. So I need to get my triangle. So here's C and S, and this part of the triangle here will be the 2500 subtract the J, because all of this was 2500. Subtract the J, that will leave me with 2500 minus J. So my triangle equation is C squared equals S squared plus 2500 minus J squared. So I'm ready to take the derivative. 2C dC dt equal 2S ds dt plus 2 times 2500 minus J. And then I'm going to move in to take the derivative of the inside. Derivative of the 2500 is 0. And I take the derivative here, and I get negative dJ dt. All right, so I have 2's all over the place to cancel. So So 60 seconds later, I need to find out how far J and S have run. So Sally runs at 20 feet per second for 60 seconds. That gets her to 1,200 feet. Jenny runs at 22 feet per second at 60 seconds, so that's 1,320. So I'll leave C there for a second. S, I'm going to put in 1,200. The ds over dt, the rate she runs is 20, plus, and I'm going to put this 1,320 in for the J, 1,320, and then I'm going to put in her rate, which is negative 22. All right, so I still need to find out what C is equal to. So here I have the triangle. So I need to put in what the S was, and that's 1,200. And then this distance here is the 2,500 minus 1,320. So that's 1,180. So to find out what C is equal to, it's going to be the square root of 1,200 squared plus 1,180 squared. So I can take this, divide through by the C, 1,200 squared plus 1,180 squared, and then I can erase this C. So that would be the answer. It turns out to be negative 1960 in the numerator over, yeah, the same thing. So it's negative, so that means they're actually getting closer to each other.